Hello. And thanks for watching this presentation. It complements the presentations Mandelbrot polynomials 1 and 2. Here we will get a little bit more details of the behavior of the self-similarity objects which we can find in nearly all parts of the Mandelbrot object. To do so, we use the self-similarity object located at the following coordinates. First, let us observe the typical fitness trampolines effect which governs the behavior of the self-similarity object and which we just saw in the Mandelbrot Polynomials 1 publication. The fitness trampolines effect consists in continuous up and down movements of the similarity object surface along the polynomial sequence. For example, when we start with a polynomial index n, with the object surface height about water level, which is painted with blue colors, then the surface height of polynomial n plus 1 growth up to high mountain level, painted with white colors, and so on. For almost all polynomials of the Mandelbrot surface sequence, the surface heights of the selected self-similarity object are showing this trampolines effect. Nevertheless, at some polynomial indices the fitness trampolines effect is interrupted by the generation of a very deep surface depression. In our case, between index 150 and 640 the very deep surface depression only appears at the following indices. If this behavior is really astonishing, even more it is the fact that the index distance between consecutive deep depression indices is constantly 39. Now we generate images from the 13 deep depression indices mentioned before, so that we can observe the evolution of these objects in time, where in time means deep depression index number. Deep surface depression at index 157. Deep surface depression at index 196. Deep depression index 235. Deep depression index 274. Deep depression index 313. Deep depression index 352. Deep depression index 391. Deep depression index 430. Deep depression index 469. Deep depression index 508. Deep depression index 547. Deep depression index 586. Deep depression index 625. The results presented in the previous pages throw the following question. Is the index distance between deep depression events constantly 39 along the whole index range of the Mandelbrot polynomial sequence? If this statement is true, then also is true, for example, such an exotic statement as polynomial index 165538679847098 is a deep depression index in our selected self-similarity object. We call this statement exotic because the indicated polynomial index is very far away from being computable with any supercomputer or even quantum computer. Let us now looking a video from the index range 150 to 640, which contains all the deep depression holes mentioned before. The video runs at a fairly high speed when it stays far from the deep depression indices, and it slows down the speed when it passes in the neighborhood of these special indices. To close this publication, we present now a video of a flight around our self-similarity object at polynomial index 235. The flight starts far away from the object, coming step by step closer to it, finally overflying the deep depression hole. After this first part of the video, the flight continues, going now to the underside of the surface to show the deep depression hole from below. Finally we will come back to the upper side of the hole and then we fly to the interior of it, where at the end we will land on the bottom of the hole. This presentation analyzed the self-similarity object at this coordinates. Obviously, to obtain a better understanding of the deep depression holes and the corresponding indices and also the index distance constants, we must analyze much more of the self-similarity objects in the Mandelbrot surface. For example, the so-called Elephant Valley contains hundreds or thousands of self-similarity objects to analyze. The results of this analysis will be published soon.